if I put that on, you can hear me? Yeah, cool. All right. What's up, everyone? Thank you. Woo! Thank you so much for coming along to talk about regular expressions in JavaScript here at a very .NET focused, and I mean, it's regular expressions anyway, and the sun is out there. You could be doing anything, so thank you. Thank you very much. My name's Nash. I'm a developer relations engineer at a company called DataStax. DataStax, we're kind of trying to build a platform, an AI platform as a service to make it really easy to build with this new kind of set of generative AI applications, and that has nothing to do with what I'm talking about, but if I don't mention that, I don't get to come. That's what we're up to. We have a vector database in AstraDB. It's a pretty sweet NoSQL store. We have a visual builder for generative AI called Langflow. That's also quite good fun to experiment with if you are trying to build with this stuff for the first time. If you ever want to follow me online, I'm Phil Nash pretty much everywhere, including my favorite URL in the world, which is just Phil Nash. Yes. I almost don't care how much the island of St. Helena will make me pay for their domain name. I will keep doing it because it's cool. I love it. So why do I want to talk about regular expressions? I've always thought that in the world of learning and teaching programming and parts of the different parts of programming, regular expressions are one of those things where you kind of get taught enough of it to be dangerous and achieve the sort of smallish things that you kind of want to in the first place with regular expressions. And then if you really like them, you go further into it. But nobody in that teaching process ever really, as far as I've experienced, warns you that they can go horribly wrong. Horribly wrong in terms of now you don't know what you've written, sure, but not horribly wrong in terms of this can take your server down, or this can just ruin a user experience. And that's the potential of the regular expression denial of service. If you write the wrong regular expression and somebody puts in, or it could be the right regular expression for all the happy path use cases that you ever wanted out of it, but somebody enters a slightly wrong piece of text, it can absolutely just kind of infinite loop or exponential loop away, not infinite, but hit an exponential path of failing over and over again. And I just wanted to kind of use this. Oh, wow. Thank you for coming, and in a regex t-shirt. That's incredible. We have all the fans of regular expressions in Copenhagen are here in this room today. All I was saying was that I don't think people teach about regular expression denial of services when they teach anything else about regular expressions. And so that's what I wanted to share today, and I want to do so with a few stories of how services have gone down. I want to do it with stories of regular expressions that existed in those services, but also in open source, and hopefully give us the tools to understand why those things go wrong and then how to avoid them ourselves in the future. I have to include this quote in any talk about regular expressions. It's an absolute classic. Some people, when confronted with the problem, think, I know I'll use regular expressions, and now they have two problems. Or, if they're at the wrong regular expression, it's now exponential levels of problems, it turns out. It's my favorite. All right, so our problem with regular expressions is the existence of backtracking. And so the first part of the talk will cover just kind of regular backtracking things that can go wrong, which are probably less likely and less of a problem for you, probably. And then the second part will be catastrophic backtracking, which, as it sounds, is just catastrophic. And here are some of the regular expressions we're going to hang out with over the next, probably won't make it to an hour, let's say 45 minutes. There's a nice one there. I'll be explaining all of these soon, but that one's a really simple one. I like that one. It's horrible. Oh, it takes so much time. This one's in Node Fetch, which is cool. That one is a bad idea for regular expression checking of emails, and that one, I don't even know what that one's supposed to do, but we'll break it down into some kind of semblance of why it was wrong, because it really was. That one, it's horrible. It's way too much, and it's horrible. So we start with regular backtracking, and this section I call Backtrack Overflow because the major story is about how Stack Overflow managed to take itself down with a regular expression. And the problem with working at Stack Overflow when you've taken your own services down is that you can't ever ask Stack Overflow how to fix it's a real annoying problem. So backtracking and regular expressions cause that problem for them. And there was the first one on the previous slide. Their regular expression was this one. This is actually more simple than it looks, because /s is just a whitespace character, and /u200c is just a Unicode whitespace character that doesn't fit into /s. And so this is a whitespace at the start of a string or whitespace at the end of a string. What's really nice about these things is that we can simplify them to see why they go wrong. So what we can do is take out the disjunction, because we can deal with just one half of it, because that's all we need. And then because whitespace characters are kind of hard to see on slides, I can replace that with a character, so we'll use A. And just say, all right, what if we were using the character A one or more times at the end of a string? How could that be a problem? Well, it can be a problem because when we actually do the work to test this, and like I said earlier, like the happy path of regular expressions is normally fine. Regular expressions take no time at all to match a string that it agrees with, but it's when they come across strings that they don't necessarily agree with. See this string here, 5 A's, I think it's 5 A's and a B? Yeah. When testing against A plus $, like A's until the end of the string, is actually not as good. It's actually pretty obvious to us that that doesn't match. It's got B at the end of it. But the regular expression engine, like the JavaScript one, and many others, will say, all right, cool. Check all the A's. We're doing well, get to the end as a B. OK, that's a shame. But we could go back to the start, lose the first character. Now we check all the A's, all the rest of the A's. And then we've got a B, and that's, we didn't get it. And the expression keeps backtracking again to just be like, all right, cool. I can actually match on the third set of it, the third A onwards, the fourth A onwards, the fifth A onwards. And whilst this is still not too much of a problem, and yeah, eventually it goes, yeah, no, that doesn't match, sure. And you're like, thanks, finally. That's not too much of a problem when there's only 5 A's and a B. But and so this is shown in the actual JavaScript engine, and JavaScript takes like 22 steps to do this. But if you add an A, if you had 6 A's and a B, it takes 29 steps to do it. If you had 7 A's and a B, it's 37 steps. And if you have 20,000 A's and a B, it takes 200 million steps. And that's quite a lot. And that doesn't seem like maybe it's a problem, but sometimes it might be. And I do just want to show, I have an example of this. This is one of my favorite things to play around with regexes, regex 101. This is that string, A plus $, and 5 A's and a B. And it says up here, actually it's saying 20 steps now. Like I said, I think this program updated recently. It has different JavaScript in it, different regex in it. But it allows you to play through those steps, and you can kind of see how it's picking up the different A's. Goes to 3, goes to 2, goes to 1, and then realizes it's not there. And if you keep adding things, this was 27 steps, 35 steps, 44. It just keeps going up, and it's not exponential. It's sort of quadratic, I think, in this case. But this was a massive problem for Stack Overflow. Why? Because in their code, I think it was for rendering questions and or comments. It was rendering something user input to the home page. They decided they wanted to use that regular expression we saw earlier, white space at the start or white space at the end, to strip that white space. Seems reasonable, ish. Except they were doing it like on every render. And then somebody popped in a comment or a question that had 20,000 whitespace characters in it, but then like something at the end. And so the regular expression engine went, oh, I've got a whitespace character, and checks the next 20,000 and then fails, and then checks the next 19,999 and fails. And so it just collapsed Stack Overflow for a solid 34 minutes. 34 minutes of no Stack Overflow for anybody in the world, let alone the person trying to fix it. Actually, I must say, finding an issue with a regular expression like that, which is seemingly simple, and fixing it with 34 minutes without the tools of Stack Overflow at your fingertips, not bad. And so what seemed like a very innocent and normal regular expression, yeah, managed to cause half an hour's outage on Stack Overflow. And all because somebody put in 20,000 whitespace characters into a comment somewhere. So you can never really tell what your users are going to do with that kind of thing, and that's where that like unexpected, unhappy path can cause you those problems. I want to show you some other kind of examples in real life of this. HTTP cache semantics is a module, it's a node module that's buried in a bunch of others. And as I was writing like kind of the idea for this talk down, I got an email from Dependabot asking me to update HTTP cache semantics. I'm like, I've never installed that personally myself, but in a bunch of my projects it was like, hey, update HTTP cache semantics because there's a ReDoS error. And I'm like, okay, yeah, no, this is a pain. There's two regular expressions in here, and these are the /* comma /* or /* equals /*. And this is just trying to split up headers, right? So we're trying to split based on commas and then key values on the equals in an HTTP request. And /* is not good because it maps with itself. So what do we got? The problem here is that /* like that, /s* 0 or 1 spaces, right? But because that can come up against that comma, any kind of amount of white space starts to do that same backtracking thing. And again, if you have a 20,000 white space characters and then not a comma, it will chew up your CPU and die. And so one of the things you might do is limit the size of the string you're looking at, or limit the size of the thing you're doing. Like avoid that star, basically. It could cause you problems. If you just look at 64 characters, that's gonna finish in milliseconds, which is great. I'm happy with that. Or you limit the size of the string coming in, right? If you have a question on Stack Overflow and it's got 20,000 characters, more than 20,000 characters, and you're like, this is a big question or a big comment, there's probably something wrong with that. Consider limiting the size of the input string. Or don't regular expression at all. Sorry for the guy in the t-shirt there, but stop it. We've got a trim function, which is not going to cause the same issues if we are trying to trim white space off a thing. Sure, it's still going to leave that 20,000 white spaces in the middle of the thing, but like that's a different error, and it's not going to take the server down. So avoiding regular expressions is always a happy thing to do here. And in the case of HTTP cache semantics, they took out the /s stars in their splits, and instead, actually, yeah, just trimmed the strings themselves instead. So avoiding regular expressions again. That's what happened there. So that one's the sort of regular backtracking that sort of runs out in quadratic time and needs an enormous input is the sort of less likely, but I guess more surprising one to happen to you. It does take that, like, I don't know how long Stack Overflow had that regular expression on their front page, rendering on the rendering of their front page. I don't know how long it was there before this particularly bad string, this bad comment kind of hit them. But you'd never expect it, and you don't find it until that horrible bad path comes along. It's probably the case that HTTP cache semantics also never fell foul of this, but now it's fixed, and we don't have to worry about that in the future. It's just magic when people go and find those things and fix your dependencies, and it's less magical that you just get an update to say, hey, you need to update this, and update this, and update this over and over again. Thanks, Dependabot. So catastrophic backtracking is much more fun to play around with because it requires a lot less input to trigger. It just requires, again, a sort of pattern in your regex that's going to cause you issues. And so the first example I have of this was in Node Fetch. This is the implementation of Fetch in Node, which has been somewhat overtaken now by Undici, I guess, and Fetch actually being put into Node itself. But for a long time, this was the way you'd use Fetch to do HTTP requests on the server side in a JavaScript program. And this little regular expression was just in a little thing. I think again it was testing something in a referrer header, just to see if this was being run on localhost, right? And so this regular expression is just saying, hey, have we got everything from the start of the string dot plus, so any of anything up until a dot, any number of times, and then ending in localhost. So it's localhost or any subdomain, anything that looks like a subdomain of localhost with any number of subdomain levels. Could be all right, except it's not. The problem with this is in the case where, again, it fails. this is a bunch of subdomains that don't have localhost at the end, so it would fail. But it would fail in a horrible, horrible way, because what it's going to do is, because we've got that dot plus, that's any character one or more times, finally followed by an actual dot, and dot fits into any character as well as being a dot. That's nice of it. And so we're first going to consume all the A dots until we get to the end. We go, OK, there's no local host. Damn it, we'll start again. So we consume all the A's but one, and then we can do that again because of the star, because we got it 0 or more times. And so it does that, and then it starts splitting these things up into like different ways to look at it, and it becomes a whole mathematical idea of permutations and combinations of different ways we could look at this, and that is going to exponentially disappear off into time. And I have a good example of this, actually. As I was writing stuff down for this talk, I decided I'd write myself a timer for regular expressions to test things against it. And if you saw Dylan's talk this morning opening up about Rockstar and how he's like, I'm going to throw this into a worker to start with so that if you do run an infinite loop in Rockstar, it's not going to chew up the browser or not going to chew up the UI. So this does that as well. We throw our regular expression off into a worker in order to do the test, and then I can time it. And so this is quite a long string in this particular case, but if I do that, we can see that the string itself takes, it's going 4, 5, it should be about 5 seconds, 5,600 seconds. Sorry, 5,600 milliseconds, 5.6 seconds. But if I add another A, another dot A, and try it again, it's probably going to double up to, nope. Sometimes it does some caching. And then it gets broken. So I reckon this is going to come in at maybe 6 seconds, and if I do it again, it'll be 12 seconds. I reckon, or it's going to, yeah, okay, 6.8 seconds. If I do that one more time, that's probably going to go for over 10 seconds. And you can see how just a bad idea of a URL, which is perfectly valid, can cause trouble with this localhost thing. 12, 13, yay, 13.7 seconds. I also learned when I was building this that Firefox will kick out about 5 seconds. It throws an error, which is much nicer for your user experience if you do manage to put something like this in. And Chrome will run that regular expression forever. It does not care. And Safari actually has some sort of better engine that shortcuts this and realizes it's fine. So if you ever go and use this timer to check things out, it's Chrome that you have to worry about. Oops. Yes, so that's what happens there. So we get this exponential kind of explosion of things that the JavaScript regular expression engine is testing, and that kind of just starts doubling the time it takes to test an incorrect string like this until your server or your browser falls over. And so this next session is a big example. Cloudflare managed to take itself down. You know, Cloudflare is quite a portion of the internet. And so Cloudflare used this enormous regular expression. And I think what they were doing with this, because they did write a report about this, it wasn't entirely clear what the regular expression was supposed to be doing. But I think it was supposed to be testing for sort of JavaScript injection in all kind of HTML pages that they're serving. Now, Cloudflare and its CDN serve an enormous amount of HTML pages, so this got run quite a lot of time when it was introduced, and immediately collapsed. Cloudflare, which is great. But what we can do with this is not worry too much again about like what's actually going on inside the whole thing. One of the things we can do to check our regular expressions is use a tool like regex. That's what this is called, and it creates yourself a diagram of what's actually going on in here. And that's useful because we can then kind of see the groupings. Now, it's a bit small. Actually, it's not bad size on this screen. But what we can see around here is that whilst this first section has a lot of stuff that it could match, it also has a big arrow around the outside that says, oh no, sorry, we have to match something in this first one. We do have to match something in this first one, so it could be a star, it could be a closed bracket, it could be any digit, it could be nan. Any one of those things, we do have to match. The second bit has an arrow around the outside, so it could be one of closed brackets, but we also don't need it. We can skip over it. Then there's a semicolon, but we can also skip over that. We don't have to have that. And then we get into a group here, and there's a thing of white space and dash and tilde and exclamation point, but this little arrow over here says we can skip it. And these guys are any character any number of times, any character any number of times equals any character number any times. And so if we actually simplify the whole thing down, we can take out all the crazy unnecessary stuff and say, okay, we need it could be any of those first things in that first list of stuff, and what I picked a quotation mark, and then it's dot star equals dot star. Ugh, dot star, you're a bad person. I did want to show you regex, but it is, it's just a super simple tool that you put a regex in, and it will come up with a diagram for you. And it's great, and you can get it as an SVG, so you can just zoom into that thing forever if you want to, or a PNG, or just permalink to this one page as well. Really useful to kind of visualize these things when you get in a large thing, a large regular expression like that. Go ahead and visualize it, make it happier for yourself. So once we've simplified a regular expression like this, we can then kind of start to see what the problems with it are. And our issue here is that our dot star, like anything any number of times, followed by anything any number of times, just overlaps with itself entirely. And again, like the kind of the subdomains, anything followed by a dot, anything followed by a dot, everything inside any string, is going to match any number of ways, an exponential number of ways, when you have dot star next to each other. And then you do have to have a sort of failure condition on that as well, so it does keep doing the backtracking. And so that equals being in there allows it to fail when it hits when it gets to the end of a string and goes, oh, we didn't get an equals. It then has to go back and test everything so many times. And it just makes it exponentially horrific. And so Cloudflare was down for 27 minutes. And again, very impressed that when a third of the internet is down, they still managed to fix it within 27 minutes. I don't think that necessarily included Stack Overflow, so maybe they got some help there. But 27-minute outage they literally put that regular expression into play. And it was more obvious that this was the cause because they deployed it and Cloudflare immediately went down, including all their internal stuff as well, which was very hard for them to deal with. And actually, if you want to, I'll share a link to an article that talks about all these regular expression failures. It links off to the Cloudflare report on this as well, because their sort of post-mortem on the whole thing was actually really interesting, especially given that, they couldn't use their internal tools to do anything either. Sorry. Hello. One thing that I know that, have I turned myself off now? Can you hear that? Okay, cool. One thing that regular expressions, I think, have always caused issues with is emails. Validating emails are an absolute nightmare, as we all know. Like the email spec actually provides an enormous regular expression that they specifically say does not cover 100% of email use cases. And so we don't even want to look at that one. That's huge. We don't even need to look at it. Anytime anyone's ever told me how to validate an email with a regular expression, it's like, look for an @ in the middle there somewhere, and we're probably all right. If you really want to validate an email address as an email address, send it an email. But validating emails has taken caused trouble for one project and it's come up in open source as well. And so the first one example of this is Superhuman. Superhuman is like an email inbox that's supposed to give you email superpowers of some sorts. I've never used it myself. But they have a client application, an email inbox built in Electron, so it's all web stuff in there. And of course, they probably want to validate that email addresses are email addresses at times as an email client. And they were quite smart about it. In the first place, they used this regular expression, which does say, anything that's not an @ followed by an @ followed by a whole bunch of stuff that's also not an @ Great. That's fine. Pretty reasonable. And then they read that thing in the email spec that says, but you can have an @ symbol in the first part of an email address if it's surrounded by quotes. Has anybody got an email address like that? Has anybody seen an email address like that? No! No one has ever used an email address like that, but it's in the spec. And the fine people at Superhuman said, that's in the spec, and maybe we should do something to deal with that. We're feeling brave. We're feeling regular expression-y. It's a Friday afternoon or something. I don't know. And they said, all right, we can do something about this. What if we change it up to this? And this says that we want the first part. We've either got not at, or there's this bit which says quotation mark followed by anything that's not a quotation mark, followed by a quotation mark. And so that anything that's not a quotation mark could be an @ which is cool. The problem with this, it turned out, was that like things that are not an @ symbol also could be a quotation mark. And so we got an overlap. They got an overlap between the pattern that says not an @ and the pattern that says we'll start with a quotation mark. And so it takes something to actually trigger this, but it did happen to them. Let's go back to that. And I put that into my little regex tester. So there's a few examples. If you ever want to go to this, it's just on my GitHub. There's a link at the end. And this is the one. If you just put in a bunch of quotation marks, then it fails. This is 5, 6. Okay, there. Okay, 6.4 seconds. Because it's matching quotation mark in both the left-hand side of the disjunction and the right-hand side. And so it will happily go back and forth, doing that over and over again, until, again, weird caching. The next one, it takes 1.3 seconds. And then it'll go off again, 2.1. 4 seconds? 3.4. And so, yeah, you end up with a string of some quotation marks, and that halts the entire UI because you're not expecting it. And so that caused that issue for Superhuman. They also wrote up a nice report on this. I really like the openness in many companies' kind of dealings with failures like this, and writing up their kind of postmortems about things. And Superhuman provided a tool that they built to try and help avoid these things in the future as well. And we'll get to those in a bit. The other regular expression email checker was Zod. Any fans of Zod in the house for runtime? So Zod provides runtime types for JavaScript. It is the runtime equivalent of TypeScript, and tries to make sure that you have types. But it goes beyond kind of basic primitive types, goes beyond just string. You can actually test to say that something is a type of an email. And at the top here was the Zod regular expression for is this an email? And this one's a bit harder to read. I'd probably put it through regexpr if I really cared about it. But the problem happened in the yellow part at the start. And what we can do is sort of boil that first part down into, this bit. So what we had here is, anything A to Z, 0 to 9, underscore plus or minus, one or more times, followed by a dot, followed by an optional dot. So we've got the question mark there saying optional dot. Oops. And because it's a question mark, 0 or 1, we can just remove it, because it never has to matter. And that leaves us with this kind of pattern here, which says characters, this is case insensitive, so it's actually any letters, any numbers, underscore plus or minus, 1 or more times, and that entire group 0 or more times. And so because that entire group can be 1 or more time and 0 or more time, it overlaps entirely with itself. And so it causes the same problem. And so, and then the rest of the regular expression goes on to say, and then more characters, and then that symbol. So it's kind of looking for email addresses that look like subdomains. No good reason to do so. We could have just kept looking at strings, but that's what happened. And so that was discovered open source and fixed, which is nice. But yeah, this kind of grouped up plus followed by a grouped up star is the same kind of overlapping that happens when you have the overlapping in previous case with Superhuman was just ats and quotation marks overlapping with each other. This is anything within that group is now overlapping with each other 0 or more times. And again, could go off to exponential. I don't think I wrote this one up. Oh, yeah, that's the odd one. So what would cause a problem here is like anything at the start, like just a bunch of A's, and a regular expression that eventually fails. So this, so it's not a valid URL at the end. And if we test that one, yeah, nasty. That's a highly reasonable email address that you could put into a system accidentally with just an incorrect top-level domain and that whole email address. And it doesn't have to be A's, right? It could be anything. It could be Phil Nash is terrible at regex. And that email address, it's done within a second. I don't know. It's a reasonable mistake to make that then causes, that same issue again. We see an exponential kind of increase in every single character that you add on because of the overlaps. And so how do we fix these? How do we recognize and fix regular expressions that are going to exponentially run off testing over and over again, failure after failure? First up, we need to look for those nested qualifiers. Those are the real kind of problems that are obvious in the first place. Those qualifiers like overlapping disjunctions. So in this little example, if we have a disjunction of A or either A or B, those A's are always going to kind of overlap. And then that plus is just allowing it to do it multiple times over just the same string. We need to look for those consecutive patterns, dot star, dot star. I mean, the star didn't help us in the first place in the regular backtracking. But if we're then adding them up together next to each other, that dot star gives us the opportunity to check every single permutation of characters next to each other in that string. And very quickly, takes a lot of time. And then finally, you do need to look out for the sort of hidden patterns that aren't immediately obvious that it's a dot star next to another dot star. If you have some kind of group that has a question mark in between those two things, that question mark can mean 0, and therefore we can immediately, we can throw it away when we're trying to look for these kind of things. If you have a question mark in between, that dot star equals question mark dot star, the equals doesn't have to be there, and we immediately fall back into our repeating combination permutation pattern. So that's what we need to look out for. How do we fix them? Well, if we're refactoring these nested qualifiers in something like the node fetch example from earlier, here our dot is overlapping with our period, the slash dot, is overlapping with the dot for anything as many, many times. And so what we could just say is, hey, that first one doesn't have to be anything. It can be just not a period. As not a period one or more times, followed by a period. That's fine. That works perfectly. We can go back to our timer and check that one out, I think. What have we got there? If I actually fix it to be anything that's not a dot, it takes no time at all. It's finished in 2 milliseconds. It's totally happy with it. Because there's now no overlap. That's not how node fetch fixed it, but it's one way we could. In the superhuman case, where they accidentally overlapped quotation marks because not an @ symbol is also a quotation mark, you can fix it by adding the quotation mark into the side of things where we're saying not quotation mark. So the fix is to go, OK, we can have quotes around anything that's not a quote, or we can have anything that's not an @ symbol or a quote, and that fixes it. In fact, we can go see that in the timer. Where's the superhuman one? This one. We said add in a question mark, quotation mark, and it's done in a millisecond, 2 milliseconds sometimes. Doesn't matter how many times we add that, it's still 2 milliseconds. It's done with it. Because we no longer have an overlap. We no longer have to compare back and forth and create a bunch of permutations. Atomic groups are a feature in some regular expression engines that allow you to avoid this, but they don't exist in the JavaScript regular expression engine, which is a shame. So I'm not going to put the syntax of that on there, but you can fake these atomic groups. So atomic group basically says, when we get to the end of this pattern, we're not going to backtrack over it. and so it immediately puts a stop to any of this backtracking. And you can kind of fake this. And so if you were to do this with the node fetch example, you do so with, and I have to remind myself of this as well, because it's just confusing syntax. We group everything up into this kind of question mark equals, which is a forward look ahead, to say, all right, let's look through all of these things at the start of our set of subdomains. And then once we capture all of those and then fail, we then use the /1 to say, OK, and then we put that group back here. And that stops the JavaScript engine actually looking back at it. It's a clever trick, but I don't necessarily recommend it. Because 3 months later, when somebody's like, what did you write this in the regular expression for? And you don't know, and they don't know, and nobody knows, and then you delete it because it doesn't seem to do anything. And then later, somebody puts 20,000 white space characters in, or something like that, and the whole thing falls apart again. If you ever do choose this, if it's the only way to do something, then highly recommend commenting exactly why that's there, because it's confusing syntax, it's a hack. I would include a link to this article on how and why it works, because that's also very useful. This will be in the slides and everything that I will share later. It's a very clever trick, but I wouldn't necessarily recommend it. It's just confusing. And so that's also not how node fetch fixed it. Instead, it was down to avoiding regular expressions again. Now, if you're looking for a string that is probably a URL and that ends in localhost, either has subdomain, either is the text localhost or is localhost with subdomains beforehand, we can test that. The string, we don't need to do all that stuff. We can just go, hey, what if the host is localhost? Or if it ends with .localhost. Same stuff. And is actually, I think, the way that they fixed it inside node fetch. They were just like, throw out the regular expression. This makes more sense. And that, I think, is actually, it's more expressive as to actually what we're trying to achieve there. So that was nice. There are other options. We could choose to use a different engine. This is not really a choice you can make in the front end, but if you're using Node.js or something in the back end, you can. Google's RE2 engine, for example, doesn't do backtracking. And so it does act differently to the existing JavaScript regular expression engine, but will never fall to any of these issues because it will not backtrack. And so there's a node binding to this. There are other languages in the world that also don't have backtracking regular expression engines in them. I think Go is one of them. And so if you're a Go programmer, you're also fine with any of these problems. Wouldn't have caused you an issue. But you also might not match other things. So there is a trade-off there that they will act differently as regular expression engines. So that's how to sort of fix those. But really, finding if you have these issues is probably now hopefully a concern that's kind of popped up in your head. You're like, have I done this somewhere? Do I have to go check all my regular expressions? Maybe you should. If they're getting user input to them, then perhaps. And there are a bunch of options for this. A whole bunch of options. So I mentioned that Superhuman both wrote up a post-mortem on what happened with their kind of issue when they tried to be smarter about email regular expressions. And so as part of their write-up, they wrote, I'll bring that back in a sec. They wrote this thing, a tool called regex.rip, and it does do a bunch of checking to see if a regular expression is vulnerable. And so this is the node fetch one, and it points out that, yeah, our issue here is down to exponential backtracking because we double with each additional thing. Very good stuff. And we could check. What else have I got? Actually, let's check the Superhuman one. You can throw that into there as well. And it will tell you, again, here's an overlap. Here's the problem. Really useful little tool. It doesn't catch everything. It turns out, I think it's a halting problem issue to actually check and fully understand every regular expression. And so it's not technically possible to really know. But regex.rip is a nice one. It's a nice little interface to try things try out things in a web interface. There are other ones like recheck, which is also a really useful tool. SonarQube, I used to work at Sonar, and this is sort of one of the reasons I came up with this talk, was because I was like, this is kind of useful. SonarQube security checks will, SonarQube or Sonar Cloud will scan your entire code base, and again, if it can detect a vulnerable regular expression, it will tell you about it. If you're using ESLint, then there are two plugins available, ESLint plugin ReDoS and ESLint plugin regex. One of them, yes, so ESLint plugin ReDoS is the same code that's behind this recheck tool at the top there, and so you can add that into your ESLint config and have that do as much checking against these things as possible. It might be not necessarily a good idea to run that every time you run ESLint, but perhaps something in CI, because it will take longer to kind of properly looking through every kind of regular expression in your code base can take quite a long time. So it's good to run maybe in CI. But then if you run it in CI and you don't care about how long it takes, use both of them. They might they might catch things that neither the other one doesn't. So that's cool. And if you ever do want to play with my little regex timer, it's got a few of those examples to play with. It's got some kind of simpler examples as well. And that's just up on my GitHub under philnash.github.io/regextimer. I did write this entire thing up as a blog post. It's one of the longest things I've written in the last couple of years. So if you are interested in kind of reading or going back over any of this stuff, that QR code will take you there. And my former employer will thank you for it. It is a useful blog post. It tries to break things down and again, links off to many of those stories and other kind of things that the postmortems that were written up by people who fell for these regular expression issues. And finally, that's actually all I've got for you. I got to 43 minutes. There we go. If you do at all want the slides for this, there is a QR code for that. That has all the links to those tools that help you out there. If you're at all interested in data stacks and what we do, that's this QR code. Yeah, that's cool. And again, I'm very delighted that some people came to watch a talk about regular expressions when we know there's going to be comedy about maths later. And you could have been in the sunshine or just hanging out with people, hallway tracking or whatever. I appreciate you coming along. Thank you very much. Again, my name's Phil Nash. I'm a developer relations engineer at DataStax. Yeah, thank you so much for coming. Thank you. We obviously have time for a bit of questions, for questions if anybody does have anything. Or we can all go and see if they've got snacks out for us between the next talks. Also, I'm, of course, around for the rest of the event, including, and most importantly, tomorrow night, after the Line Breakers play, I'll be leading us all in a rousing karaoke session. I hope to see every single one of you there down the front. Think of your songs right now. We'll get ways to select them later. But yeah, thank you so much for coming, and enjoy the rest of the event.